Aerospace welding tests generally include a butt joint and a T-joint for each metal type. In this video, I'm going to do a stainless T-joint and just kind of show you a technique that I use to prevent melt through and still get fusion into the root of the joint. I'm going to be using this cup. It's an MK14. Let's do it.
The cup you use matters a whole lot, not only for preventing discoloration, but just helping that puddle flow, because an oxide-free puddle flows better and at less amperage than one that has oxides in it. Oxides make a puddle sluggish. Some more common alloys for aerospace would be 17-7 or 15-7. This is just 304L, so just a simple wipe with acetone is all it needs. I'm going to be using 312L filler just because I had it handy in the right size. You always want to wipe down your filler. That was pretty clean. Still helps. This is a MK14 from Fixturing. I'm using 332, 2% lanthanated tungsten. And it has been sharpened on a diamond wheel on a dedicated tungsten grinder. Pretty sharp, but not like a needle. Another benefit of using a cup this size is electrode extension. That gets everything out of the way where you can see it from almost any angle, and for me it's going to get it out of the way of the camera. Since I'll be using a purge fixture, a dual flow meter makes that easy. I'll be using 30 CFH on the torch gas side and about 25 CFH on the purge fixture side, because I'm going to be splitting it into two different parts of the fixture using a little homemade Y. When you're testing on sheared metal, it's going to have a slight roll to it, and you can feel a lip, and you want that to be the welded side. That gives you just a slight edge on preventing lack of fusion, welding on that little lip. As you put it in backwards, you're going to be welding down into a rolled area that just makes it a little bit more difficult to get complete fusion into the root. You want to increase your chances wherever you can on any kind of a weld test. I've found that pony clamps are sufficient. Put a little downward pressure, make sure there's no gap, but that's all it needs before you get the first tack on there. You do want to make sure there's no gap at all. I'm getting a tack on this end. I'll show the arc shot of the tack on the other end here. I'm waiting for that post flow to make sure I don't discolor the tack. Best practice. I'm using a Prime Weld 325X. It's got a 5 amp start, which makes it nice to strike up on an edge like this without nipping it. Now we're ready to weld. Now I want to take a few dry runs to make sure that I don't get hung up on anything, and my glove is not sliding quite as smoothly as I would like it to, and so I'm going to use a TIG finger to just glide along right here. Not for heat protection, just because it's a nice smooth glide. So I light up on the tack and come inboard to the front of the tack, give it just enough pedal to where it'll flow the puddle. Then I give it a little bit more pedal as I get in there, but I'm trying not to give it any more amperage on the foot pedal than it needs to flow the puddle. And this looks like kind of cold, but again, I'm trying not to nip through it all. So part of that is not taking too big a step forward. Sometimes I even back up a little bit, especially if I get hung up a little bit on the filler wire hand. I'll back up over that thick part of the puddle, give myself a half a second to get that wire in there again. If you step out there and hang out there in the front of the puddle and you hang out too long before you add filler metal, that's where you can get melt back. Of course, just too much amperage will give you melt back as well, but you kind of want to have a tight arc and just enough amperage to flow the puddle well. I put a camera on the front of the machine. That's 56 amps right now to do what you're seeing here. The old rule of thumb about 1 amp per 1/1000th of thickness doesn't really apply that much on joints like this, because you're really using minimal heat and you're not trying to penetrate all the way through. In fact, you're trying not to penetrate all the way through. Again, the requirements are kind of different. It's kind of vague in the AWS D17.1 spec. It doesn't do a great job of addressing melt through and suck back and things like that. But a lot of test shop administrators don't want to see any melt through at all on a joint this thickness. Now coming up to the end here, I'm getting ready to start backing off the foot pedal right about here and tapering off amperage down to 0 amps. I gave it a little foot pedal tap there to extend the post flow, make sure I don't get any discoloration on the end. And that MK14 ceramic cup pretty much made a discoloration-free stainless weld. But did I melt through? That's the question. We'll take a peek at the backside. Doesn't look like I nipped it there. The other backside doesn't look like I nipped it there. I'm going to call it a win for a practice joint.
This cup is a great choice for chromoly, stainless steel, Inconel, titanium,
and especially good for super alloys used in aerospace. We have this graphic to help you identify what type of TIG torch you have, so you'll make sure to order the right kit.